So I start my talk with a question which for a neuroscientist is rather unusual, a what question, because usually scientists ask for the how something functions. But as a philosopher, you're well known, you're well familiar with what question. However, the question what is the brain is probably not so familiar to you, because usually you just take the brain granted as a gray, pure matter. However, and as much as it surprises you, we don't really know what the brain is about. So Arthur Schopenhauer in the 19th century, whom I really consider the first neurophilosopher in the literal sense of the term, he spoke of a gray pulpy device. I added the gruesome. And the question is really, at least for me, and I think for my generation of neuroscientists, how does the brain is connected to mental features like self and, for instance, changes, or other mental features like volition or consciousness. And here, philosophically, I already make a very, very important presupposition. I speak of mental features and not the mind, because you introduce me as a brain and mind specialist or brain and mind person. I'm not. Because in my latest book I said we don't need to assume the concept of mind on a purely conceptual level, because it leads to erratic consequences like the mind-body problem. I don't go into that today, but what is important to keep in mind ontologically for you as philosophers, I make a sharp distinction between the concept of mind on the one hand, which I consider to be an ontological concept or metaphysical concept, and the concept of mental features. I am for mental features, but that doesn't mean that I need to also endorse the concept of mind. I know this is very puzzling for philosophers of mind, who usually consider these two concepts as interchangeable. So just for some ontological, some conceptual background here. So, and I start my talk with two models of the brain. Because as you know, science is not just about empirical data. Scientists usually tell you that. We just need data and that will decide everything. However, when you practice science or neuroscience like me, as a philosopher, you'll be surprised how much conceptual stuff comes into your empirical data. One is really surprised. In our lab meetings, we discuss really methodological, technological, empirical details, and then we switch to some conceptual things. Meaning the kind of concepts, the kind of models you presuppose strongly shape your experimental paradigms and the way you interpret the data. So, I tell you the typical model of the brain these days in neuroscience, which is often tacitly, implicitly taken for granted, is the brain is like a car. That goes, it's a purely mechanistic view. Let's say the stronger you push the gas pedal, the faster your car drives. So there's a purely linear, determinate relationship between the gas pedal push and the speed. That's a purely linear model of the brain, and that really is a lot, reminds you probably of behaviorism or its extension, cognitivism, cognitive neuroscience. You again might be surprised that I put cognitive neuroscience and behaviorism into one pot, but structurally, cognitive neuroscience is just an extension of behaviorism. So, how does this work? You have an external stimulus, here, the beautiful Colosseum of Rome, and that is used as stimulus to stimulate the brain, could be in rat experiments, human experiments. And then you see some stimulus-induced or task-evoked activity here on the right, there, here. And what is important, that this activity, that the stimulus is considered to be sufficient for that activity. Meaning that activity here on the right can be sufficiently related to the stimulus. And then, of course, immediately the question comes up, where on earth does the self or the consciousness which you experience in association with that task-evoked activity come from? If that activity is sufficiently related to the stimulus. So by default, this model leaves a gap. Now, and then, of course, you assume some add-on mechanisms. When you look into the current neuroscientific theories of consciousness, Tononi assumes integration, global neuronal workspace, and so on and so on. But that add-on, of course, doesn't capture the real thing. So this is by default. But the problem is here not the choice of the add-on mechanism. The problem is the model of the brain. Next one. The brain is not like a car. So now imagine you're stepping out and your bike or your motorbike or your car is just spontaneously moving without you doing anything. It's not yet a self-driving car from Uber or from Tesla. Yeah? And it's continuously moving in certain spatial-temporal trajectories. So there's a certain space-time dynamics. You will hear those terms a lot throughout my talk. This is exactly what your brain does. This is the spontaneous activity of the brain, and you might have heard it also as resting state activity of the brain. Nobody knows what it is and why it is for. I hope I can give you some ideas on that, or at least I think. So how does this work? So here, you start with the brain itself, its intrinsic resting state activity. Here are the red arrows, you can see them here. And then with that, you approach the stimulus. So the stimulus-induced activity here, upper right, is a hybrid. It's a mixture between the intrinsic activity and the external stimulus, and in particular, how they interact. And the nature of this interaction is not just additive. We don't know that. We have a lot of research going on exactly that. And I assume the central hypothesis is, for me, that this spontaneous activity has a certain spatial-temporal structure, remember the car, and that spatial-temporal structure is central for associating mental features to the stimulus. You see again, pay attention to my formulation. I say the mental features, self-consciousness, volition are associated with the external stimulus. A neuroscientist would not say this because they say consciousness comes with the content himself. Very important. And you see the formulation, where does it come from? Of course, it's not out of my own pocket. It's a formulation which is very much a line and a model with Immanuel Kant's model of mind, and I wrote actually 2012 a paper on that in Trends in Cognitive Science, Immanuel Kant's mind and the brain's resting state. So I assume that this spontaneous activity's spatial temporal structure is central for associating mental features to whatever stimulus. I also wrote a book in German about that. So, and that's basically the background against which I set my talk. The self and its brain, a neuroecological view, and I complement it by a temporal spatial view. So, and obviously, as you already see, I'm a neuroscientist, but I'm also a philosopher. So my talk without going much into a conceptual definition or conceptual what is the self, I just take it as an operational definition. This is me, you see your every self, you see yourself in the mirror, and you just take it for granted that it is you, and you have a certain experience, it is you. However, as a psychiatrist, I know very well that there are many conditions where your sense of self is altered. Like in schizophrenia, you experience Jesus, Buddha. In China, I have seen some Maos. Actually, it's cultural dependent. It's very interesting. Yeah? So that means there's a certain construction process going on. So it's not written in stone, it's not a fixed entity, it can change. Very important. Yeah? So when I speak of self in the following, I don't want to go into all the conceptual riddles. I know that there are as many concepts of self as philosophers and neuroscientists, at least. So I come back to that towards the end of my talk, that I try to a little bit chart the territory there. But just let it sense of self in an operational definition. My talk will basically include three main arguments I want to make. The first argument, empirical findings suggest the self to be intrinsically temporal spatial rather than cognitive. I don't deny that it is cognitive, but there's a deeper layer of self, which is temporal spatial. Second argument is empirical findings suggest the self to be intrinsically neuroecological. So it is embedded within the world. You will see this, and from there I infer. And the third argument is that we need a relation-based ontology in form of the world-brain relation to account for the necessary condition of possible self. So the first 2 points, temporal, spatial, neuroecological. Third argument will be the ontological point. And I will probably don't spend too much time on the empirical stuff. If you have more questions on that, I will just try to give you a rough outline. So first question, first argument, temporal spatial nature of self as suggested by empirical findings. First question, of course, here, how can we investigate the self experimentally? Has been done a lot in recent neuroscience, that we present stimuli like the own face versus another person's face, own name versus another person's name, or trait adjectives like today I'm here in Würzburg, tomorrow I'm in Ottawa, and so on and so on. Yeah, and let's say we can present you a picture from Ottawa, winter, -40 and snowstorm, which I'm sure for you is not self-related. For me, it's highly self-related because I have to survive. Good, so that's what you do, and then you put people into the scanner, and then you see various regions. You see particular regions lighting up here in the middle of the brain. That's why we coined this set of regions cortical midline structures. And interestingly, these cortical midline structures have special features. However, please, I don't want to go into the debate. It does not mean that I locate the self in the cortical midline structures. It is clear that self-related activity, depending on certain balances, can occur all over the brain. So it's really a basic feature of the brain. And that's something you will hear often from me. When I say basic feature, I distinguish the self as a basic feature from the self as higher order cognitive feature. And that's something we inherited in Western philosophy, that the self is a higher order cognitive feature, a meta-representation, self-awareness. I think, therefore I am, and that has a long tradition in Western philosophy. And that's where you see, where if you confront conceptualists with empirical data, can be very fruitful. So then the next thing, and that was really a major finding for me and has been replicated by many others since, that we found that the activity, in particular these regions, during self-related stimuli, strongly overlap and does not distinguish from the ongoing level of resting state activity. So it's very paradox. The more self-related your stimulus is, the less the activity in these regions changes. From a cognitive perspective, it's a disaster, because you would say self is the most important thing. So you would expect the strongest activity and the task-evoked activity related to self to most strongly stand out when compared to the ongoing spontaneous activity. However, the opposite is the case. So from that, I inferred that maybe there are certain features in the brain's spontaneous activity which sort of encode information about the self. Yeah? So that maybe your ongoing spontaneous activity is intrinsically self-related. So that sounds completely paradoxical from a cognitive perspective. However, so we have this overlap. So then the question is, what are the exact features of the spontaneous activity that could mediate the sense of self? So and that leads me to spatial and temporal structure. And that leads, there's a whole a tale, of course, the concepts of time and space, which I don't want to go into. I remain here on the empirical side. I will come back to that later. So for instance, one typical hallmark is that you have the brain spontaneous activity constantly varies, constantly fluctuates. And it constantly fluctuates in different frequencies. Can be very slow frequencies, which we can measure with fMRI. This is the frequency range in Hertz, very fast as in gamma. It goes much faster to 200 and so on. So, and what is important, there's a certain structure again to that, a certain temporal structure. These frequencies have much more power than these. Go to the seaside, drive to the Mediterranean here, and you will see you have some big waves which do not occur very often but are extremely powerful. And then you have a lot of small waves which are not very powerful. Same with the brain. And important, you get this time series out of the data, EEG, fMRI, or whatever, and there is a certain structure in there, for instance, this one here. The higher the frequency, the lower the power. That is called scale-free activity. Yeah, you can measure that. Then you have a certain autocorrelation, that the correlation that the neuronal activity from one time point to another time point correlates with the other, temporal autocorrelation. You don't need to understand the details, but what you need, these are mathematical models to describe the temporal structure of this time series. And the emphasis is here on temporal structure. Yeah? I'm using the concept of structure, philosophically goes back, among others, Kant, form, organization. That's sort of the conceptual context which I'm operating here, but of course drawn into the empirical domain. So, and now the question is, are these features of the temporal structure of the spontaneous activity, are they related to the sense of self? That's the question here I'm raising. And indeed, that's what we did in recent years. We did studies in fMRI and EEG where we showed that the temporal structure, here you see it again, here's a frequency, faster frequency, slower frequency, and you see again much more, here's the power, much more power in the slow frequency than in the fast frequencies. And you see each of these lines is one subject. You see huge inter-individual differences. And I will tell you later why that is so. So each of us here sitting around the table will have a slightly different power spectrum, as we call it. And that, as the data show here we did a self-consciousness scale as a questionnaire, psychological. Self-consciousness was directly related to inter-individual differences in the degree of self-consciousness. Of course, now you can argue your operationalization of the self is rather weak here, and that's true, because we mix consciousness, reflection, self, but it's very hard to tackle. So, but what we could see here, and yet in the EEGs here as well, we had different measures of this temporal structure in the spontaneous activity, and that directly predicted inter-individual differences in your particular private self-consciousness. So these data showed us that maybe indeed the spatial temporal dynamics, the structure of the spontaneous activity, is somewhat maybe has information about the self. So that means that maybe the self itself has a strongly temporal spatial features. So that's why I speak of a temporal spatial characterization of the self. That's why we coined the paper here also the temporal signature of self. And the idea is now, and that's a working hypothesis we're currently pursuing, so here you have the different neuronal measures of temporal structure in the neuronal activity. Yeah? This is power law exponent, autocorrelation, window modulation index, cross-frequency coupling for the experts. And these describe different features of temporal structure: temporal nestedness, temporal continuity, temporal integration. And the idea is now that these features are also of temporal structure are also manifested in our subjective experience of self, what phenomenologists like to call spatial temporality. So that basically the common currency, as we said it in a recent paper, between the neuronal activity and the mental activity might consist in this temporal spatial dynamics. So we're currently conducting many studies where we try to bring in these measures on the psychological level of self and then relink them to the same measures on the neuronal level. meaning we try to create a psychological a time series of the psychology of self, or your subjective experience of self, analyze this with these measures, and then while recording neuronal activity, we have the neuronal time series analyzed with the same measures. Yeah? So that we say maybe the bridge, the common currency, as we say in the paper in Physics and Life Review, really consists in the space-time dynamics. Yeah? So more philosophically put, how does neuronal activity transform into mental activity? I would argue it's a spatial-temporal transformation. And again, you might be puzzled by the way I formulate it. I say neuronal activity transforms into mental activity. You don't see this in any text on philosophy of mind or in neuroscience, because there you usually try to map the mental activity onto the neuronal activity. I say, no, you need to start from the other way. Because methodologically, if you map, you have a mind-based approach. That means you have a certain model, a certain presupposition, which you saw it in the beginning, I try to get away from. Yeah? So that's on the empirical side. Note that this is purely empirical. I have not yet made any ontological assumption about mind and body. I know philosophers like to be very fast with this and say, you make a presupposition, you contradict your own self. No, I was indifferent here. Yeah, no way. I'm sure you find something here. So then this is also an interesting thing. We published it last year. 2 years ago. Time is running faster than I can follow. Yeah. So personal identity, you know, this is a long discussion going back to Locke. You did a lot of work on that. And it's temporal continuity. And we were asking, how is temporal continuity constructed by the brain? And let's say, and these, if you have a certain correlation of time points in neuronal activity, you create a neuronal continuity. And the idea is that maybe then lead to personal identity. So that's an empirical access to personal identity. Of course, I know that I neglect the other side of personal identity, what you are interested in, the norms and the values, the practical aspect. That I have no idea, admittedly. So, but then you can see, and why I'm interested in that, because as a psychiatrist, I'm often confronted with problem here. Yeah? So when Locke speaks of memory as a criterion, Parfit 2, then I would argue maybe it's a spatial temporal memory. It's not a cognitive memory. It's not a memory about specific contents. That's what I mean by cognitive. So it's a very liberal way of cognitive here. What I mean is it's spatial temporal patterns. Yeah? So, and I think I already made that point, the temporal spatial, how neuronal activity transforms into mental activity. So I start from here, transformation process. And with this concept, I'm very much in line with biology. Chemists, biology, they use these kind of terms. It's very common. But the neuroscientists don't use them. Yeah, they have a different view. And that's why we say we really need to have a novel neuroscience. Good. Now you'll be surprised that I show this picture. So you say, yeah, all nice and good, maybe the data, we even believe them, but I don't believe the theory. I don't believe the transformation. And of course, with that, you hit me into my heart, because that's the core point what I want to make on the empirical side. So I try to give you an analogy. Look at the paintings by Leonardo da Vinci. The guys, you all know this is the Last Supper from Milano. And look, it's a 2D canvas, but you have the feeling as if it's in 3D. Yeah? You have a depth in the room, and you have the feeling that all these guys are basically alive. In the next moment, they step out of the painting and grab you or whatever. Yeah? So he creates sort of a 3D spatial temporal dynamics on a 2D canvas. Why do I show this? Because I say that's exactly what happens with our brain spontaneous activity. It creates a virtual 3D space-time dynamics. And that's what mental features for me are about. So what we are trying now to do, characterize mental features like self, like consciousness, and psychotic symptoms in terms of spatial temporal dynamics and specific. Yeah, so that's why, for instance, psychiatry, I speak of spatial temporal psychopathology. Yeah, so it's a virtual space-time thing. Space-time only understood in a phenomenological sense here, not in an ontological sense. That's, be careful here. Yeah, but of course it has implications, which as a follow. So now, come to the second point. So that, I hope, suggests that the self is intrinsically temporal spatial rather than primarily cognitive. I don't deny cognitive levels of self, but there's the upper layers. There's a deeper layer, which is very important. Second argument, empirical for so far you say, Northoff, all nice and good, purely empirical, I'm not interested in your talk, because it's just brain, it's just empirical. You haven't said anything about the world, henceforth you haven't said anything about ontological issues, let alone about the existence and reality of self. Fair, you're absolutely right. If you want to make an ontological assumption, you need to make a link of the brain / the self to the world. And that's exactly what I'm trying to do in the second step. Again, it drives me a little bit by empirical finding. Here we did a study where we showed early traumatic life experience like bullying or the big brother didn't give you the food and so on and so on. And what we observed is that the degree of early traumatic life events here, measured with a specific scale, childhood traumatic questionnaire, directly related to the structure of activity entropy, the degree of disorder in the medial prefrontal cortex in adulthood. So that means your early life events are somewhat encoded into the organization of your space-time dynamics. That's entropy, for instance, about. Yeah? So meaning your brain is a highly sensitive organ. And this is important. This is not about cognition. This is not how you cognize a certain event, but that a certain event is sort of transformed into space-time dynamics in your brain. Here we did another recent study where we did animate versus inanimate touch. So robotic hand versus a real hand. Yeah? And the real hand was quite modeled like the normal hand. However, and we did both a subjective as well as a neuronal investigation. So, and we did a behavioral experiment where people were confronted with the real hand, the animate hand, and the inanimate hand, and they had to subjectively judge time, how much synchrony they feel with the animate or inanimate hand, and how close spatially. Purely subjective and self and other. And then we did some fMRI task and rest. Briefly, the behavioral data, I always love the behavioral data here because it's so simple. So they had to judge on a visual analog scale the degree of self-relatedness. So yeah, and they, the animate target, meaning the real hand, was judged much more self-related than the inanimate. But it was also a hand. Yeah, so far for artificial creatures here. Yeah. Then perception of time, how much you feel in synchrony. So when you feel with others, you resonate, or when you hear music, you feel in synchrony. Same thing what we ask here, how much you feel in synchrony with the hand, much higher for the animate than inanimate hand. And then the perception of time, how close. So and these were about 80 subjects. So it's robust data, we could replicate that in another sample. So it's really amazing, just your subjective experience really differs. That means that your subjective experience is really tuned to the animate environment, yeah, to which you live. Yeah? So what does this mean now? That the brain must somehow be embedded in part of that animate environment / its spatial temporal structure. And that's exactly what we could show here. Here, like we see that the resting state scale-free activity, which also predicted the self in the earlier studies, the same measure, Polar exponent, predicted the task-evoked activity during animate stimuli, but not during inanimate. Yeah? So that really tells you the spontaneous activity dynamics is tuned to its environmental context. Yeah? It's adapted. So maybe the stochastic properties of your environment are somewhat transformed into the stochastics of the space-time dynamics of your brain activity. And you see later why I emphasize this. So you see what I'm doing here. Let's say there's a relationship between resting state and self, and that both are grounded by their relationship to the world environment. So this is very important. I do not deny that there's a cognition of the self of the world environment, but what I describe is a deeper level. Yeah? And that's very important here. Yeah? And from that I infer our brain spontaneous activity in itself are intrinsically necessarily so. So I make a strong statement here, which I haven't supported conceptually, I agree, but I empirically suggest that scale-free stochastics of environment shapes the brain and itself. And now by that I introduce the concept of world-brain relation and world-self relation. I will come back to that later. Note that is the order of the two terms is very important. So that leads me to my third argument. Now it becomes more philosophically, and now you probably say, now the neuroscientist goes crazy. That's why I'm a psychiatrist. So third argument, relation-based ontology with world-brain relation is necessary condition of possible self as spatial, temporal, and neuroecological. Note the notion of possible. I'm arguing here of necessary condition of possible. I like to use the term predisposition for that. I speak of ontological predisposition here. Yeah? So I'm not, and I will come back to the actual realizations of self towards the end of my slide, towards the end of my talk. So that's what the data, I think, at least what I think so suggests. You have a temporal spatial world-brain relation. I showed you this one, the relation here, that this is temporal spatial. Then I showed you this one and the relationship to this one. And so now the idea, what does it imply ontologically? So now my question, now I turn into a philosopher and say, what kind of ontology do I need in order to account for, to make them plausible with the empirical finding? The emphasis is here on plausible. Yeah? So this is very unusual for you as philosophers, because usually you set your ontological assumptions right from the beginning. And then you infer everything from it. As a neurophilosopher, I can't do that. As a neurophilosopher, I have to be open to possible revisions of my ontological assumptions on the basis of the empirical data. It does not mean that I infer my ontology from empirical data. That's what Kant accused Locke of when he said that Locke is a physiologist of reason. It's an empirical ontological fallacy, and I agree with that. But you can try to make them adjust each other. Plausibility, I'm saying here. It's a methodological principle. Yeah? So that's the question. And then I say, I go a little bit into ontology. Of course, I cannot go into all the details. But if I take a very broad picture, one can describe two alternative forms of ontology. First, very classical, particularly in the Western tradition, element-based ontology. Properties or substances as the most basic features of existence and reality. Important, elements or properties are primary and relation is necessary. This sounds banal to you because you say, of course. However, that's a presupposition you set, because you can think about other possible presuppositions here. And this presupposition is, as I see it, the basis, for instance, for the mind-body problem, which I think would not be feasible as such if you would presuppose an alternative ontology. That's what I argue in my recent book. However, on the fringes of Western philosophy, there have been also other forms of ontology. Process ontology, Whitehead. That's why I wrote 2 papers about Whitehead and the brain. And more recently, very interesting, structural realism, who comes more from philosophy of science, also assumes that maybe relation are primary and elements are secondary, or at least they co-occurring. Yeah? So here the focus is on relation. Applied to world and brain, these two alternative forms of ontology would look like this. In the case of element-based ontology, I would assume the world and the brain, and then I would say, okay, somehow they constitute a relation. And that relation modulates neuronal activity a little bit. Yeah? However, I make a much stronger claim. I say, look, the brain would not be a brain if it weren't related to the world. So the space-time dynamics of the spontaneous activity is necessarily shaped by the environment, meaning the brain ontologically is relational. Yeah? So that's the claim here, and that's what I mean by world self-relation. Let me try to explicate these two forms of ontology. Here, element, you have properties, substances, and then secondary relation. Relation-based ontology, first the relation, then the properties. And now you say, no, Northoff, this is circular. In a way, you're right, because there can be no relation without any properties. So that's why you have different forms of structural realism. You have a moderate ontic structural realism, where you have the co-occurrence of relata and relation. And that needs to be distinguished from eliminative or radical ontic structuralism, where you basically say relata are not important at all. So I here subscribe to moderate OSR, the co-occurrence of relata and relation, meaning the co-occurrence of world and brain, and that relation shapes the brain. Yeah? So, and that's why I say the relation of the brain to the world shapes and determines the existence reality, at least of the world. So, and then of course, how is that possible? That's where I would argue temporal spatial features. So now here I use time and space in an ontological sense. And here I would presuppose, I cannot go into detail of that, time, space, dynamic time and space in the sense of, for instance, Leibniz. Just one remark here to the alternative ontologists. When you go into the Asian parts of the world, they have much less problems with relation-based ontology. Yeah? When you go back to Chinese philosophers, the old, for instance, Zhangzhe, you see a lot. So it's quite amazing. They feel much more comfortable with that and cannot understand ours. There's a real cultural differences. And that dents even into students of neuroscience. How do I now imagine the relationship, the ontological relationship between world and brain? So now I'm speaking as an ontologist. I bring in the Russian dolls. You all know them. And you see this, the biggest one is probably the world, and the smaller one is the brain, nested within the world. Yeah? So in that what we call is a scale-free. You have the same shape, different sizes. That is called scale-free activity, which is empirically, but here used as an ontological principle. Temporal spatial nestedness. Yeah? And so maybe this is the brain, maybe this is the world, or I don't know. But I think you know what I mean. And what is important, that the brain is nested within the world, not the other way around. That's why I speak of world-brain relation and not brain-world relation, because that would be a confusion between whole and part. So Bennett and Hacker, in a way, were right when they accuse neuroscience of a merological confusion. That's really true. It's a real problem, also in philosophy of mind. Same on the temporal side, temporal nestedness. These different frequencies, remember, they have different power. The faster, less powerful frequencies are nested within the more powerful, slower frequencies. And the world has much larger frequencies, much more slower frequency, like seismic earth wave, which the brain doesn't have. Yeah? So there's a temporal nestedness. Nestedness now understood as an ontological principle of space-time characterization of relation-based ontology. World-brain relation, ontological characterization. I think I already made that point extensively. Relation-based ontology, relation rather than isolation as element, as primary and basic feature of the brain. Brain is intrinsically temporal spatial features are constituted by their relation to the world. And don't misunderstand me, that relation of the brain, that nesting of the brain within the world is not a passive process in the Humean-like sense. It's a very active alignment. In this way, you align actively to the world, to the music when you dance. But you align to the music. The music doesn't align to you. Yeah? That's what I mean. Yeah? You're basically you're nesting yourself within the music. With only and then you tacitly you tap your feet. This is important. No, I need to spend some time on this. Directionality. When I give the same talk in the Western world, and you see it also on the back cover of the MIT book, immediately people say it's brain world. It's automatic. You see it on the back cover, one of the, it's a brain world, continuum brain world relation. I strongly distinguish. World-brain relation means that the brain is nested within the world. It's like when you adapt to the music. Brain-world relation means you cognize the world. You may represent the world, whatever that is. Yeah? But that's a difference. Then you impose yourself upon the world. Then you give the directionality is distinguished from brain world. So this is central. And you will see this in the next, I think in the next slide. That is very important. And ultimately, somewhat, we can discuss this in the 4 E's, embodiment, extendedness, enactment, and embeddedness. Somewhat is still an isolation presupposed between world and brain, because otherwise that extension would not be necessary. But we can argue on that. Third, the world-brain relation is about the constitution of the self, yeah, in the interaction with the world versus cognition. That's, of course, brain-world relation. So the world constitutes the brain's intrinsic features through world-brain relation, which in turn allows the brain and itself to cognize the world, brain-world relation. So let me illustrate, because this point is philosophically absolutely central. So I would argue that the world-brain relation is philosophically absolutely central for mental features. And in my MIT book here, I also argue that it can replace the mind-body problem, but I don't want to go into that. Yeah? The brain-world relationship is at best epistemic, or if not empirical. So here you see, I assume it's not just a passive, it's an active process, an active alignment process. When you listen to music, you actively align. Your brain can phase synchronize with the phase onset of the music. That's why you dance. Yeah? And that's tacitly, you're not cognitive aware of that, you just do it. Yeah? So that's why I put this red arrow here. Yeah? So it's not the passive model of mind or brain as suggested by Hume or the empiricism. Yeah? And that gives you a temporal spatial nestedness, and yeah? And that, I would argue, is an ontological concept here, because that's a relation-based ontology. Yeah? And then, of course, it goes also to the other direction. That's the brain-world relation, and that's the way you cognize, or cognition of the world, and, of course, all the empirical stuff. Yeah? Then I would say that this on the left amounts to a concept of relational self, and we can argue that whether that somehow touches upon what you mean by person-life view. And that, I mean, really relation itself in an ontological sense. And as such is temporal, spatial, and neuroecological. And you see I use the terms neuroecological, now temporal, spatial in both ontological and empirical senses. I use the term neuroecological basically as a node term, which is right at the node between ontological and empirical. So just to chart the methodological territory here, a little bit of my concept. And here, for instance, I would argue we have the cognitive self, and that's, for instance, representation, volition. Then, of course, you might say, and I just spent one slide on this, could be again open for the discussion, what about the body? You could argue that I still have a very neurocentric view of mental features, which is not true because it's a neuroecological view, but still the brain figures predominantly. So I would argue that the body as such, the objective body as it is called, is not the body which is assumed to be relevant for mental features in theories of embodiment. What is it imputes? The lived body. And how does that come across? The interoceptive input from the body, like the heart, what you did a lot, from the heart, and the studies by your studies, the studies by Talon-Boudry, is processed by the brain. So let's say the cardiac input is processed by the brain. And that transforms the objective body into a lived body as part of the world and related to the world. So you can see here again, the brain somewhat aligns itself to the temporal spatial dynamics of the heart. And that ultimately, however, we experience our body not as isolated as lived body, but as part of the wider world. So that means your body-brain relation is a subset of the wider temporal spatial framework of the world through world-brain relation. So, and here, for instance, you could speak, I charted conceptual territory a little bit of a bodily self. And that, of course, we all know that body-brain relations are central for emotions. Yeah? In emotion effect, that's probably really the closest comes. And what we are currently trying, we're trying to link different space-time subjective experiences and patterns with different emotions. Yeah? For instance, we have a paper in bipolar patients, depression mania, where too slow inner time speed transforms into negative effect. And of course, in a way, it's very logic, it's very common sense. If you have the feeling that nothing changes anymore, subjectively, of course you become depressed. And that's exactly what these people experience. And we could show that the neuronal speed is also too slow in depression. So you see that sort of this very basic concept, let's say the ontological predisposition, world-brain relation, of a self, of a possible self, might then also yield more concrete of the actual realizations of self. So that's where I try to, basically what I try to provide is a more firmer, ontologically, empirically plausible ground for the different concepts of self. Summary. First argument, I hope I could at least partially induce the idea in you that the self might be intrinsically temporal spatial rather than primarily cognitive. And that, I don't need to tell you, goes in part against the tradition of Western philosophy. I say Eastern philosophy is a different story. Second argument. Empirical findings suggest a neuroecological basis of the self in the world, and literally that certain events in the world are transformed into the space-time dynamics of the brain, which in turn impacts our self and its mental features. Classical example, post-traumatic stress disorder, things like that. I showed you the early traumatic life events. I showed you the animate versus inanimate space. Third, I said that relation-based ontology with world-brain relation is a necessary condition. I should have marked it more correctly. A necessary ontological condition of the possible self, note, as distinguished from the actual self, as temporal, spatial, and neuroecological. And that in turn provides the ground for the realizations, the empirical realizations of the different concepts of self. And with that, I close my talk. Thank you very much.